Now I know what you're thinking. Mr. Jones, can I go get a bowl of ice cream? Absolutely. And then when you come back, I want to answer a question of my own. Why do electrons flow from the anode to the cathode? So to answer my question, it's because everything in nature naturally moves from high potential energy to low potential energy. It's like when you're standing on the kitchen table and you jump off, you have put yourself into a state of high potential energy because gravity is going to be pulling you down, and so then you'll move from high potential energy to low potential energy, which would be when you hit the bottom of the ground. And electrons are the same way. So at the anode, electrons have a high potential energy, and at the cathode, they have a low potential energy. So as a result, electrons always flow from the anode to the cathode. So from zinc to copper, or any of the other metals on the activity series. And that force that drives electrons from the anode to the cathode is what we call voltage. So voltage is comparable to gravity, which is something we've all experienced every time we've fallen down or jumped off of something. So gravitational potential energy is equal to force times distance, or work. And so like if we have a rock tied to a string, if we were to pull that string to raise this rock up to our height, the amount of work that we would have to do would be equal to the force that we applied to get that rock up times the distance that we had to pull it up. Now we would say this rock possesses potential energy because if we were to give it a little nudge, it would fall back down. So the amount of energy that it would release on the fall would be equal to the energy that we had to put in to raise it up to this height. So we put in potential energy, and now it has potential energy so it can release kinetic energy. And its natural state of position is going to be to fall back down and release that potential energy. So it's moved from low potential energy to high potential energy. So the delta V, or the change in volts, is going to be equal to the change in potential energy divided by the charge in coulombs for a particular reaction. And so this would tell us how much voltage is generated by a particular redox reaction. So then think of the cathode as the ground and the anode as the sky. So in order for an electron to move from the cathode to the anode, you would have to physically pull it from that place to that place. So this will not occur naturally. Naturally, everything moves from high potential energy to low potential energy. So this right here would be a non-spontaneous or non-thermodynamically favored process because it is moving from low potential energy to high potential energy. Instead, electrons will move from high potential energy, the anode, down to the cathode, which is low potential energy. And as a result, this change right here would generate 12 volts of electricity. And so this would be the potential energy difference that would give us like a 12-volt battery or a 9-volt battery, whatever it is that we need to use in our devices. And so this potential energy is built into the reactants, and when we combine them together in a galvanic cell, we're going to convert that potential energy that is built into the reactants into kinetic energy, which we generate into electrical energy. Now this is just an analogy. There is no little dudes with rocks and strings. It's actually a lot more complicated than this. But to get into what's actually happening, that goes into physics and quantum mechanics, stuff that we don't really have time for. The general take-home message is electrons move from high potential energy to low potential energy, or the anode to the cathode. The potential energy difference is what generates voltage, which is what pushes those electrons from one place to the other. And as the voltage pushes the electrons, we generate an electrical current. Here's a summary that you can read through, or if you printed out the notes, it's already on there. Read through this and just make some mental notes and some side notes on this. Okay. 5 different terms that we're going to use interchangeably. This is like thermodynamically favored and spontaneous reactions. They mean the exact same thing. So different ways of saying the same thing. EMF, electromotive force, is the force that causes electrons to move, aka voltage. Standard EMF, this would be the electromotive force under standard conditions, so 25 degrees Celsius, 1 molar concentrations, or if we're dealing with gases, 1 atmospheres. E of the cell is the cell potential. E with that little zero again means standard, and then cell voltage. All of these generally mean the same thing, which is a volt. So a couple different things are used in different places or under different conditions, but all of them have the same units of voltage, and we'll talk about all of these later on in this unit.